Wow, I know I look super excited coming up here, but let me tell you, I'm very anxious. Luckily, you don't see my speaker notes, so... Anyway, good evening, everybody. First of all, thank you very much for coming today. Do you hear me well? Yeah? Okay. I know it's not easy to take time to attend one of these events after a working day, so really, really appreciate it that you're here to listen to our presentations. Oh, sorry, this is not the beginning of the presentation. Okay, don't judge me. I am just, manifesting vacation, so the whole presentation is going to be filled with subliminal messages of the beach and good weather. It's just something I need today, I'm at the age of a breakdown. Anyway, my today's talk is going to be around AgentCore realities based on my experience building agentic AI systems on AWS. And I'll try to make it not boring. First of all, for those who don't know me, let's get to know each other, let's stay in touch. My name is Marina, and I'm a tech lead working at Bedrock. I specialize in the development of web, mobile, and AI solutions. And recently, there's been a growing demand for agentic systems, so I saw an opportunity to actually build something that I can say is production ready and share the lessons learned. I'm also a founder of Cat Bytes community, which is an online community for women in tech. And as some of you may know, I am a part of co-organizers of the AWS user group UK community, as well as this one, which is AWS AI in Practice. And yeah, let's start with the presentation. So today's presentation is going to focus around AgentCore, as I said. And as an example, I'm going to be talking about an incident investigation agent that I've been building over the last couple of weekends. And the key learning takeaways, aside those, what I really hope is that the lessons I share today will save you a lot of time in the future, maybe, when you try to build your first AgentCore runtime agent. And here I'm going improvisational a bit and start to interact with the audience. Can I ask a question? How many of you already tried AgentCore? Not so many. It's just as I expected. Thank you so much. It just proves one of my lessons learned about the technology being still new, and we'll get to there. So, and now it's going to sound like a commercial, but what if life incidents didn't have to be so stressful, right? That's not where I was supposed to start. Just as a bit of a premise, why I decided to build an incident investigation agent is, well, first of all, since the AWS Summit in April this year, I've been wanting to try AgentCore, and I sat down and I thought, what problem I want the agent to solve, because I just don't want to build something that is not bringing me any value, right? And I understood that probably one of the most stressful periods in my job is when something happens with the live environment. I don't know how many of you can agree with that. I hate those moments, and they can happen outside of working hours when you're sleeping, and all those memes about engineers waking up in the middle of the night. I cannot relate to that because it didn't happen so often, but it would be good if we had an agent, a system that would monitor your production applications, and if something goes down, it would just investigate for you, collect logs, analyze the root causes, and eventually send you an incident investigation report. That was my initial objective, and I don't want to get your hopes up, it's not what I built, but I have foundations, okay, and I consider it a production-ready foundational agent as it is secure, it is scalable, and what was the first adjective? Secure, scalable, and consistent, which is always difficult when you're working with probabilistic systems, right? And that's why I decided to build an incident investigation agent. Now it's time to simulate a problem just because I have it, and why not demo it? Let me try to do this. I think I need to... You know what? It's okay. I'm just going to tell you what I'm doing, okay? I will not drag my other screens into this screen. I'm going to SSH into one of my Elastic Beanstalk servers, and I'm going to kill Jinx.
Drag it to the left if you want, or to the right. It should come onto the screen.
Oh, no, it's okay. Oh, I need to reload it. I hope it will not ask for authentication again. Okay. Sudo. I hope it's dev environment. TL. Stop. And Jinx. Okay, it's done. And let's just pretend that it didn't happen, and we can continue talking about something else. So, incident investigation agent, the main features, it's very simple. It monitors live applications, it investigates incidents, it can even attempt safe remediation actions and send incident investigation report. Okay? It will save me some time for sure doing this manually, and also can decrease some downtime if something happens outside working hours and it's a critical application that should be highly available. I lost my mouse. Do you see it? Okay, here we go. Okay, I understand that at this point it doesn't have a lot of tools and actions to play with, but as I said, I consider it production ready because it's scalable, secure and consistent. And also let's talk about why use AgentCore. So what is AgentCore, right? AgentCore is Amazon's platform designed for running agents, basically for hosting agents. And at its heart, it has AgentCore runtime, which provides the secure runtime for executing the agent code. And it comes with a lot of built-in features and advantages, like, for example, session-based isolation, where every session actually creates a dedicated micro VM, and it has isolated memory, CPU, and is destroyed after every session. So there is really no risk of like cross-session data leakage. It also supports popular AI frameworks. It's framework agnostic, so you can use Bedrock, you can use Anthropic, Google. It supports long sessions up to 8 hours, which means that we can build really complex multi-step, multitask agents. It has consumption-based pricing, and it can automatically scale without us being worried about planning capacity in advance. And now the moment of truth, I really hope that it worked and we received the incident investigation report. Let me just double check that. Do we have it or not? Okay, reloading Gmail. Maybe it's still processing because sometimes it takes a while. But so that we don't lose time, I'm going to show you the report that I generated before when I was like 1 hour before session. I just received it. Okay, sorry. Let me drag it at this point. Here we go. It's very ugly, but hey, we have an incident report. It says, what does it say? I don't see. Okay, it looks like it identified that the gifted app environment was reported as unavailable with a status code of 502, and did it try to remediate the environment? The Elastic Beanstalk development environment was restarted as a low-risk remediation action. Pretty cool, right? And if we check, I need now to see. Oh no, what did I do? Might help. Oh, here we go, here we go. Thank you. I did it again. Okay, okay. I understand. I'm just a bit confused. What did I want to say? Yes, I wanted to check if the environment that was down, that we broke, is actually restored. And as you can see, it's already restored and working. Okay, this is enough for the demo. So difficult, oh my gosh. Where is the presentation now? I'm in a panic mode, so not capable to respond to instructions.
You're fine. It's all okay.
Thank you. My voice stopped shaking, I hope.
So what doesn't help is everything's reversed on this screen. So.
Go on, mate, you got this. Left a bit, left a bit.
Oh, nice. Oh my gosh. Okay, so you all saw that. No, it worked. It sent an incident report. All worked, and that was already a big part of my presentation. And that is the only time I'm doing the demo during this talk, but it's going to be available on GitHub, so if you want, you can just play around with it. So let's just have a really quick overview of the architecture for this incident agent. We have an event breach that runs every minute and triggers a monitoring lambda, which pins different infrastructure components. In my case, it's just going to be front-end and back-end URLs. And if something doesn't return the 200 status, it will create an incident in DynamoDB and invoke our agent that is guarded by Amazon Bedrock guardrails. And then agent takes over and starts to check the logs, Elastic Beanstalk, tries to restart the environment, and eventually sends us the email, hopefully. And it did. So yes, this is a high-level architecture overview, but I think it's going to be useful in the following slides to have an understanding of the infrastructure for this one. So as you could see, it's a simple agent, right? It has limited tools, it can only do few things, but from my perspective, what it took to actually build it and to get it to production ready is, you will see. Because initially when AgentCore is marketed and when you are at the AWS Summit and everybody is talking about how easy it is, they made it so easy. It's just AgentCore deploy, create and then deploy, which is cool. You have access to AgentCore CLI. But then 2 weekends later, and this is my first joke of the presentation, this is what happens and what I saw. It's not supposed to be readable. It's just all the issues that I faced while building it, right? But we're thinking about the beach and vacation, so let's move on. I lost my mouse again, I'm sorry. Here it is. So the point here is that creating an agent is quite easy. It might be a matter of a couple of CLI commands, but actually making it reliable and production ready takes time and effort, specifically configuring semi-agentic flow, because you need to understand which parts of the systems you want to take out from the probabilistic flow, right? And that's why there are so many issues with using AgentCore today. I don't want to say anything bad about it because I love it. It has a lot of features, but it's still new technology. So reality check number 2, choosing a model. I didn't know whether I should eventually include the slides or not, but I decided that model selection is becoming a challenging task, so it's important to talk about it. And because I'm talking about it, I'm going to mention all the issues that I faced at the very first step of selecting a model. So when you're running AgentCore deploy, you have a selection of a few options for the models. And then if you have a different certain model in mind, you need to manually configure it, which is really not a big deal, just something I noticed. What is interesting is that, did you know that there are some models that you cannot use without having prior approval? You have to submit some form, you have to receive approval from Anthropic. I think it's about Anthropic models, right? And then some models, when you try them, they give you an error that they can only be invoked via the inference profiles. I understand if I had more experience with AgentCore, I would probably know what that means, but basically inference profile is just a Amazon managed, Bedrock managed endpoint that sits in front of one or more models. And then you don't have to call the model directly. You can call the inference profile, and Bedrock will do a bunch of stuff for you, like routing, cross-region, I don't know, a lot of stuff. And it sounds pretty cool. It's just that I didn't know about it at the time. What surprised me is that there are some models that don't actually support tool use, which is the whole point of building an agentic system, and cost and latency, yeah? So I guess what I'm driving at is, let me read my notes, is that before building an agent, it's important to make an informed decision about the model. And the focus of this talk is not about model selection, but I really wanted to share the video from last year, reInvent, Mastering Model Choice, just because, and here we go, some fun facts. Did you know? Did you know there are more than 2 million models nowadays on Hugging Face? That is a crazy number. And actually, a chief product officer, I believe, at Hugging Face, he said that a new model is created every 10 seconds. And Amazon Bedrock already supports more than 100 models. And if you think about it, selecting a model is already becoming challenging by itself. So they start to create tools to evaluate models, like to help you select models. But I'm not going to focus on this today. I just wanted to share this video with you. And I'm also happy to share a presentation with the resources later. Reality number 2. At this point, I had a working agent that is compliant with AgentCore requirements. And the next logical step, you would think, is just to deploy to AgentCore. But it wasn't as straightforward as I thought. Well, as per documentation, you would just run AgentCore deploy command. But it just didn't work for me. And this just proves my point that the tech is still new. The error messages are often vague. They are often non-descriptive, and it's quite difficult to debug, especially when the community support also is not catching up as fast as we would want that. So I had an issue that this command was just not working for me. And when I started to debug it, I understood that AgentCore assumes Python by default, so I had to install some additional tooling for deployment, like UV is something Python related. And then I had an issue with a CDK schema mismatch. Eventually, I'm going to save you some time. I didn't spend a lot of time debugging CLI commands or opening an issue. What you could do if you face similar issues, you can just ditch a part of the AgentCore abstraction and use CDK commands directly to deploy an agent, right? It comes with pros and cons, but I really didn't have time to debug the CLI command, so what I did is I just used CDK deploy, really. Okay. So now we are moving from build and deployment problems to the agent engineering problems. I'm going in chronological order here. At this point, we have an agent deployed to AgentCore runtime, even not with AgentCore command, but nevertheless, we have it deployed, it's running, but I start to notice already some performance issues. I noticed that it still behaves as a helpful conversational bot, but you would think that, if you're building an agent on AgentCore, it could behave like an agent, but fundamentally it still tries to be helpful conversational assistant. So I noticed that it happened probably because the agent didn't have enough observability, context, information, tools to provide more useful feedback, useful responses, because I wanted it to investigate root causes, to try to remediate. I didn't want like generic troubleshooting advice. At this point, when the agent had only a couple of tools, like checking back on the front end, it would give a very, very generic advice, like front end is unreachable, try this and that, but it wasn't investigating. And that's the reality number 3, that agent intelligence is bound by tools. Also, this one is interesting. Looks like it doesn't fit in here, but it's just something I found out, which is funny, because at certain points, I knew that I only gave the agent a couple of tools, but in the investigation report, I started to see agent doing something weird, like calling tools that don't exist. But then I found out that they actually do exist and the agent has access to them, only it was not explicit. So just be careful sometimes when you're using boilerplate project like with AgentCore abstraction. You might have some tools that are implicitly imported from an MCP server. Yeah, I think that might save some time if you, because I was very surprised. I was like, where is this coming from? And now you would think that because we are jumping to reality number 4, agent jumps to conclusions. Okay. So as I said, the AI agent was still trying to behave as a helpful assistant, so more conversational, generic responses. And this so-called conversational dominance leads to issues like the agent would stop often investigate after revealing the first issue. Just an example. The agent, if there is an issue in the front end, for example, and the agent sees it, it immediately thinks, okay, I know what the issue is, I'm going to reply, and this is a premature synthesis that it's doing. And in this case, it's not really a big problem, it's just something we can solve with prompt engineering, asking agent to really please consider all parts of the infrastructure before jumping to conclusions, because you need to provide comprehensive report. Because I understand you revealed an issue with front end, but then there might be other issues, and when something happens in the live environment, you really need comprehensive information. But there are also situations when prompt engineering is not enough. I know it's not news, but in agentic systems, right? I'll start over again. At this point, we have an agent built and deployed to AgentCore, and it has access to the following tools. It can check front and back end, it can check logs, it can attempt to restart the server, and send investigation email. But when I simulated the issue with front end, for example, front end was unreachable, the agent understood correctly. Okay, front end is unreachable, and now I have additional prompts saying I need to investigate other parts of the infrastructure. And it goes to Elastic Beanstalk, and it sees that it's healthy, and what it does, it restarts the app servers. And I'm asking why? Just because it's a very probabilistic system. And some things cannot be solved with prompts. And that's where we need to move the safety control, some guardrails from prompt to actual tools. So we cannot control what the agent decides to use and when, because if we could control that, if this would be deterministic part, then it wouldn't be agentic, right? But it's still important because we cannot control that, but what we can do is configure tools with their guardrails. We can say restart in Elastic Beanstalk environment is not allowed if it's already healthy. There's no point to do that. And after this change, I started to receive investigation reports, and I noticed that the agent still tried to restart it, but it was blocked. And yeah, there's nothing I can do about it, to be honest. So the point is that operational systems require policies, and that's why we moved some safety controls sometimes to other places to be more reliable. Okay, now to more complicated issues. I think hallucinations are more complicated issues because before we are dealing with problems like more engineering related, right? Deployment, runtime, architecture. But then I started to compare the investigation reports against the actual traces of what was done in the system, and I noticed that the agent started to hallucinate non-existent tools, as I mentioned, and stating in the investigation report the timestamps of I did this, I did that, which is completely made up, and it's quite dangerous, I think, because you should be able to trust the investigation timeline to know what was done when, which tool was called when. And this was just one more responsibility that we had to take away from the agent and put it in a more deterministic conditional flow. Okay. But you see how little by little we're taking part of the agent responsibilities. And at this point, all it really does is just investigates, tries to remediate. And that's the whole responsibility of the AI element of the system. And that's why I think it's correct to call it partly agentic system for incident investigation. And you might ask the question at this point if it's really worth having an agent. And I would say yes. I was asking the same question myself because I manage multiple production workloads and really a lot of apps, a lot of environments, complex infrastructure, and agentic solutions, they are actually helpful in situations when you have a lot of use cases, ambiguous use cases. So I would say it's still valuable and I'm sticking to it. I'm just going to scale it so it's more useful. And it leads us nicely to another reality that observability becomes more important than intelligence. Okay, don't take it literally. It's just an exaggeration for the presentation. Okay, but what I'm talking about is just, I was really worried that agents just started to invent audit traces. And initially, I was focused on things like how can I improve investigation reports, prompt, I was thinking about tool selection, but eventually I realized that none of that matters if I cannot trust the agent. Because unlike traditional software, agents don't always take the same path. If you have the same problem, it might take completely random different paths, and the exact sequence of tool calls can change, and the reasoning and conclusions can change, which means that it's really hard to debug. So, as I said, I started to add investigation pipelines, recording tool execution history, looking at Bedrock invocation logging, exploring AgentCore observability features. And the lesson here is that observability for agentic systems is not optional anymore. Because if we cannot trust what agent does, then there's no really use of it. And architecture for long-running agents. Now we are moving to more architectural considerations, and we're going to talk about agent invocations. It shouldn't be a hard question. When I was planning in my head how it should work, I knew already that it's going to be invoked by a monitoring layer, by a Lambda function. But what I didn't consider since the beginning is that Lambda functions is not a long-running service. So it really cannot wait for the agent to finish its work and then to open incident report. I had a whole flow of how I wanted it to work. So at a certain point, it had to finish for the agent to finish, had to wait for the agent to finish in order to confirm that it's finished and the investigation is done and I can open incident report. But it didn't work. Logically, you might think that was a stupid decision. And eventually, you're right, I moved the agent invocation still stayed in Lambda, but AgentCore provides us this very nice feature that your agent can basically confirm immediately that it accepted the request to the caller function, and then Lambda can just exit immediately and the agent works in the background, which is how it's supposed to be. So I'm not even sure why I'm talking about this, because sure, nobody will make the same mistake. But okay, just something to share. And there was a whole architectural decision-making process around this incident management status, no? Because when do you open the incident? How do you not open 2 incidents for the same problem? There was a lot of stuff in my head. And I just wanted to share with you this because it is important to plan the ownership of different responsibilities of the system. Look what happens, for example, if the app goes down, your Lambda checks, does the incident already exist for this issue? And if it exists, this is the end of the process. If it doesn't exist, Lambda will open an incident in DynamoDB and will invoke an agent. And then the agent, there can be multiple issues with it. There can be invocation error, that happened to me. There can be agent crash during execution, that happened to me. At this point, it will all end in failure, and the next time Lambda runs every 1 minute, and there is still an issue with the app, it's not going to open the incident again to avoid. So there was a whole process, you know. My point is, put critical operational state under deterministic software control. So in this case, monitoring Lambda layer is responsible for incident state management, right? For your use case, just analyze the main responsibilities of the system and decide which components should own them. And that's it, I think. Okay, this is our final reality. I also put page numbers in the corner. I hope that helps, you know, see the progress of how many slides already finished. We're almost done. Of course, how can we talk about agentic AI without talking about security? It's just there are new angles of security we need to think about. We need to think about who can invoke the agent, which tools the agent has access to. You know, IAM permissions have to be very strict and limited. And we have to think even about the things like what data and permissions the tools have. If the tool has access to Lambda logs, then it's important for us to already think about what we are logging when we are writing Lambda functions, no? I don't know about you, but for me, before, I wasn't super worried when I had to log some logs on the server side. Not on the client side, you never expose them, but there's not a high risk in certain situations to log them in the server. But now we have to think about it very carefully, because sometimes what you are logging can be used as a prompt injection, can become part of the system instructions for the agent. Maybe from a user perspective, user can manipulate logs somehow that the logs will contain something dangerous for the agent, like ignore previous instructions, shut down the production. I'm exaggerating here, but you know, it's real risk that we have to think about now. And I had to go through all of the security questions and make sure that the agent is secure and safe for production use, and make sure that you carefully check what you're logging, as I said. Another concern was runaway investigations. Because the agent runs in a loop until it decides that the goal is reached, we cannot control how long it's going to run in a loop, how many tools it's going to call. Actually, we can, and we should control that. So always double check, based on your use case, what would be the maximum number of tool calls you could allow for your agent to use, or for how long your agent can run, right? Because if you don't set these limits, there is a cost risk. It can just run in a loop for so long that it's going to cost you a lot of tokens. And at this point, I think it also becomes a security concern. So how do we mitigate security and cost control risks? I already gave a bit of a spoiler for this. But first control what we implemented was IAM scope permissions. Specifically, we need to review and check. I already said that, right? I think this is just a summary slide. As I mentioned, to check IAM permissions. Check that you're only given the agent the list of tools that you approved, that you know how they work, what they have access to. Make sure that remediation policies are inside the tools for high-risk actions, or not even for high risk, for the actions that you think need some guardrail. Make sure you have this inbuilt in the tools, like we did with the restart in Elastic Beanstalk environment. And then you have also Bedrock guardrails, which are inbuilt features that are available to you. You can put the agent behind the Bedrock guardrails, and you automatically have like prompt attack safety mitigation action, right? Which is what I'm using in this use case. And then human approvals for dangerous actions. Oh, it's the last slide. Okay, looking back, this was probably the biggest lesson for me, is that building a reliable agent was mostly software engineering eventually, because creating and building, deploying an agent itself was not super difficult to work on probabilistic components. But what took time is really all of these little things around it. And you can ignore this sentence. I thought it's going to be funny, which is obviously not. But yeah. And key takeaways. Again, agent intelligence is bounded by tool availability, which we covered. Prompt engineering alone is not enough. Probably you already knew that. And not everything should be agentic. Observability is mandatory. And these are all based on my opinion, by the way. I think observability is mandatory if you build an agentic systems. That security requires multiple layers. Long-running agents require different architecture. And building a reliable agent is mostly software engineering. And if you want to argue with me, we can do that during pizza. I am done. Thank you very much.